So here are the derivatives of the other trig functions, although wait, this okay, I'll move that. Gonna move this. There we go. Okay. So they're on your formula sheet, right? I would just keep your formula sheet handy. They're in the book. Keep that handy as well. Well, it'll sort of be handy because you're doing questions out of it. So, and remember, important thing is use your outlines or the timeline so you know which questions to do, right? Because we are kind of jumping about in the book, and so we don't expect everything from one section, right? We'll be coming back into them later as well. So I thought maybe we would start with just doing this one, right? Like, so where does it come from? And you could drive all the rest of them similarly, right? So we know sine x and we know cos x, and we know that tan x is equal to sine x over cos x. So, so let's say y is equal to tan x, which we know is sine x over cos x. Then y prime, by the quotient rule, is the bottom, right, which is the denominator, times the derivative of the numerator, which will be cos x, minus the numerator, brackets, times the derivative of the denominator, which is minus sine x, over the square of the denominator. And so we end up with cos squared x plus sine squared x over cos squared x, which is 1 over cos squared x, which is secant squared x. Okay, so similarly, if you want to do the derivative of secant, you could just do 1 over sine, or you could do 1 over sine x, right? Or you could do sine x to the negative 1, right? So either one. You could do it as a quotient 1 over sine, or you could do it as sine x to the negative 1. Not to be confused with sine inverse of x, right? So like this is not that, right? One is the inverse sine, as in what angle gives me 1/2 for a sine? Okay. Yeah, so that's tan. So let's just do a bunch of other ones, right? So f of x is equal to x cubed secant x. So this is a product, right? We'll always work our way back to familiar territory. We're going to use the product rule, and then we'll do the quotient rule, and then we'll do some other stuff and examples, right? And it's just, you know, so what's the product rule say? It's f, so it's x cubed, times the derivative of g. So let's be explicit about that here. Right, so it's x cubed times the derivative with respect to x of secant x, right, plus the secant of x times the derivative with respect to x of x cubed, right? Now, oftentimes we don't bother writing that out, right? We would just actually do, you know, we wouldn't write this line, but, you know, because we're just getting into this, just, you know, get us thinking about, yeah, what is it? Okay, it's that. So what's the derivative of secant? So we look back at our sheet, right? And you're going to have the formula sheet, right? Although, you know, maybe at university you have to memorize these. The textbooks always say, and you should memorize these. So, well, you know, I would, you've got a formula sheet, so. What is that? That's secant x tan x. So sec x tan x plus, okay, and this derivative, I'm going to do this. This is 3x squared, right, times the secant of x. So 3x squared secant x. And, you know, that's good enough. Right? That'll do. You don't have to factor an x squared secant x out or anything. It doesn't really get you anywhere. Okay, so there we go. That's good. I need more room for the next one. So. So we're going to do d by d theta of theta squared sine theta over 1 plus cos theta. But not only that, but we're going to evaluate that when theta is equal to pi over 2. Okay, so that notation of evaluate the derivative at a particular value of the variable. In this case, we're using theta just because why not? Trig, theta, they go together. Mostly you're going to see x's in the book, I think, and that's fine. So that means we need to get the derivative. So what is that? So there's quotients, there's products. And let's be a little explicit here. So it's the denominator, right? 1 plus cos theta times the derivative of the numerator with respect to theta. So d by d theta of theta squared sine theta minus the numerator, theta squared sine theta, times the derivative with respect to theta of the denominator plus cos theta over the denominator squared. Okay, so that's being pretty explicit. You have to know, I mean, you could just go to the next line, right? You could just actually do the derivative of the theta squared sine theta. Just scooch this up a smidge. And I'm just going to shift left a little bit because there's lots of stuff to write. So it's 1 plus cos theta. Now this derivative is a product rule, right, which we're really familiar with now, so I'm not gonna, and besides we just did one where we got explicit on it, and we'll just do this. So it's theta squared times the derivative of sine theta, which is cos theta, plus derivative of, plus, let's do the sine theta first, times, the derivative of theta squared, which is 2 theta, minus theta squared sine theta, times, luckily this derivative is just what? I say luckily, because otherwise I wouldn't have squeezed that in there, right? So the derivative with respect to theta of 1 plus cos theta is 0 minus sine theta, just minus sine theta. All over so now we just want to clean things up a little bit here, right? So we're just going to kind of collect these and neaten them up a bit. So 1 plus cos theta times, okay, what do we got? Theta squared cos theta, so that's okay the way that sits, right? So theta squared cos theta plus 2 theta sine theta. And it's all I'm doing is rearranging, right? I mean, we're putting numbers and variables ahead of, ahead of the sine theta instead of behind. And then we've got, what will this be? Plus theta squared sine squared theta all over 1 plus cos theta squared. And, that's about as far as we need to go there. But now we've got to evaluate this, right? So we want to evaluate this at pi over 2. Okay, so when theta is pi over 2, okay, we're just going to go through, rewrite this exactly, except where we see theta, we're going to put in pi over 2. 1 plus cos pi over 2. Pi over 2 quantity squared cos pi over 2 plus 2 times pi over 2 sine pi over 2 plus.
Excuse the interruption. Arco and Billy, please come to the main office, please. Arco and Billy, please come to the main office.
He's in school on a Friday afternoon. I was just betting on the odds of him being in school Friday afternoon. Yeah. Okay, so what's cos? So we need to know cos pi over 2 and sine pi over 2, right? What's cos pi over 2? 0. What's sine pi over 2? 1. Okay, good. So we got 1 plus 0, so that's 1. We've got pi. Oh, well, that's 0, right? So that just takes this out. So bracket. So I'm gonna kind of keep things in their relative place. This first set of brackets will be this. I open the bracket. The thing in front of the plus sign is this. Okay, so if you're looking back at it, sort of saying like, I'm not gonna just leave that off totally and then have this because it gets a little confusing. This way we could say, well, that must be this 0. Then I've got a plus. This will be pi, right? And this is 1, so it's just pi plus pi. Plus. And then what do we got? Pi squared over 4, and that's just 1, right? It's 1 squared. So pi squared over 4, pi squared over 4, over 1. Right, again, that's 0, 1, plus 0, 1, squared, 1. So we got pi plus pi squared over 4, or if you like, 4 pi plus pi squared over 4. Either one of those, right? Who cares? They're the same. And again, when you do multiple choice question, and it's like, I got this, and I don't. Then look for equivalent forms, right? It just might be in a different form. All right, nice and easy, right? Just the usual calculus stuff, just lines and lines of, But really, it's a fairly mechanical process, right? Okay, let's do a few more. Sec squared 2x. Little chain rule here. So remember what that means, right? Okay, sec squared means you take the secant of the thing and you square it. Okay, so that gives us the outer function, right, which is squaring, and so it becomes 2 times secant 2x to the power of 1. And then we go in to do the secant of 2x, right? So it's the derivative of the outer function with respect to the inner function times the derivative of the inner function, and the derivative of secant is sec x tan x, so it'll be secant 2x, tan 2x, and then the 2x, right? So the derivative of that is 2. And so neatening it up, we got 2 times 2 is 4. We got secant 2x times secant 2x, which is sec squared 2x, and then we've got a tan 2x. And that's that.
Where did that last 2 come from? The second last row?
This 2? Oh. When you're doing the derivative of secant 2x,
Yeah, so it's secant.
it's secant 2x times tan 2x. That's the outer function, and the inner function is the 2x times 2. So the derivative of that. It's a double chain rule. Right. So you have to do chain rule on secant 2x. You've got secant, which is the outer function, you got 2x, which is the inner function. So when I take the derivative of secant 2x, secant 2x tan 2x, then I have to do the derivative of the inner function. Remember that video? I wish we could use chain rule more often. Well, we use chain rule a lot. Like, it's just. Okay, so let's do tan x over tan x plus 1. A nice little quotient bit thing here. So the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator right, plus 0 just over the denominator squared. Whoa, it's like it just looked inside the, whoa, what's going on here? And you're saying we were wondering the same thing. Okay, so yeah, it's kind of like puzzle, right? Sort of like, look, well, where are we going with it? Well, okay, look, if I do this tan x sec squared x, I'm going to get a positive one of those. I'm going to be subtracting this away from it. So then you say, well, okay, I want to expand this, right? And then it's going to go away, and then we'll simplify. So expanding this, we get tan x, whoops, times sec squared x, okay, this times this, plus 1 plus sec squared x, minus tan x sec squared x, right? So this, gone, over tan x plus 1 squared, and ultimately then, right, this and this. So we get secant squared x over tan x plus 1 squared. So just a little quotient rule, a little derivative of tan, a little derivative of, well, that's all it was, right? What's the derivative of tan? Okay, 2 more. Want to be nice, give you time to. The cosecant of x plus x times the tan of y. So a little implicit differentiation, right? So we can't express this explicitly. You cannot write this as a function of y. Because you got that tan y sitting there, and it's not like you can just, you know, factor out a tan or something. We'll just factor out a tan. Factor a y out of the tan. No, it doesn't work that way. So we do the derivative with respect to x of this, and then this, and then this, and there's a product, and there's whatever. So, okay. So the derivative of cosecant is, on the other side, what is cosecant? Minus cosecant cotan. So here's an interesting thing with the, if you look at the stuff that's negative, the derivatives of the co-functions are negative. The derivative of cosine is negative. The derivative of cotan is negative, and the derivative of cosecant is negative, right? Those are the 3 that are negative. If for some reason you happen to memorize them. If not, remember, you can always derive them from first principles if you had to, right? If I need the derivative of cotan, I can just do the derivative of 1 over tan and use the quotient rule, or I can go tan x to the negative 1 and use the power. Okay, so if for some reason you were forced to memorize them and didn't, then that would work for you. Okay, so we've got negative cosecant x cotan x. So that's the derivative of cosecant. Plus x, and then the derivative of y, which is going to be sec squared y prime, okay, when you do the derivative of tan y, plus tan y times 1, the derivative of this, right, is equal to 5y prime. Okay, so the derivative with respect to x of 5y is 5y prime. Okay, let's get the y prime over here, factor it out, divide and conquer, right? So minus cosecant x cotan x plus tan y is equal to 5y prime. Actually, you know what, I'm going to y prime 5 minus. I'm going to shortcut a smidge there, right? I mean, I could have written 5y prime minus, oh, I forgot the x. I can't move it over. There. I'm subtracting x secant squared y from both sides. I'll factor out the y prime at the same time, so give me y prime, and then 5 minus that. And so y prime is equal to negative cosecant of x, cotan of x, plus the tangent of y, over that. Easy stuff, huh? Yeah. All you got to do is pound away at this stuff, right? That's the entire secret. You just gotta do lots of it, right? Secret.
Umar, could you please go to the ID office when you get a chance, Umar?
VV. Okay, so determine the equation of line tangent to, we could graph this too, right? So tangent to y equals cosecant x minus 3 when x is equal to 5 pi over 6. Yeah, we don't even have the point, so we got to get the point, right? It's always what we ask. Isn't that what we ask calculus every day? What's the point? So, okay, here, let's say that here. The point. The point is so the point is y is equal to cosecant of 5 pi over 6 minus 3. Now, if you don't happen offhand to know what the cosecant of 5 pi over 6 is, then you might say, well, it's 1 over the sine of 5 pi over 6 minus 3, and then you do whatever magic you do to get that figured out, right? So that's going to be 2 minus 3, or negative 1. So the point is 5 pi over 6, negative 1, right? Because that's a half, right? Sine of 5 pi over 6, that's like, it's the reference angle pi over 6. It's in quadrant 2 where the sign is positive, and the reference angle pi over 6 has a value of 1/2, so it's a half. 1 over half is 2, and 2 minus 3 is negative 1. So there's the point on cosecant x minus 3, which is just a cosecant curve vertically translated down 3 units, right? Okay, that's the point. You're going to get a line. You need a slope. What's the slope? Slope is the derivative.
I know, but it really is. I did it on a racer. Whatever.
So the slope of the tangent line is y prime. which is, and what's the derivative of cosecant? That's like cosecant minus cosecant cotangent. Right, and then the minus 3 is like, yeah, it's gone 0. Who cares? Okay, we got a point, we got the slope, but we need to get the actual slope at the point, well, at the x value, right? So, what do we say? So our slope is going to be minus cosecant 5 pi over 6. See, all this, not wasted. We know what that is. Cotangent 5 pi over 6. So we know that the cosecant of 5 pi over 6 is 2, so we've got negative 2. And then, no, thank you. And then we've got the cotangent of 5 pi over 6, so we got to figure that out. All right, well, we already know where 5 pi over 6 is. Got a reference angle pi over 6. Cotan is cos over sine. That's going to be, but the cosine is negative there, so it's going to be a negative root 3 over 1. Negative root 3.
Yeah, it's just right. Yeah, that's what I got.
So the slope is 2 root 3. So there's the slope. There's the point. Your favorite way, whatever you like. So y plus 1 is 2 root 3 x minus 5 pi over 6. Y plus 1 is 2 root 3 x minus 5 pi over 3. Right, because 2, 6, leaves you 3 on the bottom there. Multiply through by 3 because we can't have, remember, 1/3 is not an integer. Leaving us in, so we got 2 root 3x minus 3y.
How come the root 3 doesn't multiply into the 5 pi over 6? Yeah.
Oh, you're right. I don't know. How come it doesn't? So what am I missing? Oh yeah, root 3 on the end. So 5 pi root 3. Root 3. Root 3. Over 3. So over 3 here, but not here. Yeah.
You have to multiply the 2 root 3 by 3 as well.
You're right. I do, don't I? 3 plus 6 root 3. Okay, 6 root 3x minus 3y minus 5 pi over 3 minus 3. Move that over. Go over here. Go away. Minus 3 equals 0. All right, okay. So I'm just going to pause this, go to Desmos, and graph the two things just to see, hey, what does this look like? And okay. So oh, now it went away. All right, what's there?
I don't know. Yeah, he was like, I want to be fucking you guys. Can you let us fly it? They were like, you know what? It's like we're not all.
Anyway, so there's the graph. Cosecant x minus 3, and here's the graph of the tangent line. And there's the graph, and I don't know where the intersection went.
Oh, and I think I thought.
Yeah, we saw it earlier, and now it's gone, so I don't know why.
My sickest game is what? 29. Yeah, because like
Close by there. I don't know why I can't find it now.